Okay, everyone, moving on to our next three properties of exponents. We have product of powers. So product of powers looks like this. If I have a to the m times a to the n, notice that I have the same base. So if I'm multiplying with the same base, then that's going to be a to the m plus n. So a good example of this, you guys have already been doing it when we multiply. When we have like x times x squared plus 1, back to chapter 2, if I were to distribute this, do you notice that the x and the x squared have the same base? So this would go to x cubed. What you did was you took the 2 plus the 1 and you got x cubed. That's what this is telling you right there. Now, quotient of powers, if you have a to the m over a to the n, that's a to the m minus n. Now, what this is really telling you is, let's say we have like x to the 5th over x cubed, and typically your teacher would have you write 1, 2, 3, 4, 5 over 1, 2, 3, and then you come up here and you start crossing things out. So get rid of it, 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 which leaves you with x squared. So really all you did was you took the 5 minus 3 and you got x squared. Then we have power of a power. So this one is if you have a to the m quantity raised to the n, that's going to be a to the m times n. So this one is saying if I have x squared and then I take that and I cube it, really what you're doing here is you're doing x squared times x squared times x squared. I'm doing 3 of them. And if you're doing x squared times x squared times x squared, well, that's back over to this one where you're just adding. So 2 plus 2 plus 2 is x to the 6th. So we could have skipped this step and just multiplied the 3 to the 2 and gotten x to the 6th. Okay, let's try these. So letter A, 3 squared times 3 to the 6th. So they have the same base, which means we're going to add the exponents. So this is going to keep the same base. You don't make it 9, you don't multiply the bases. You're just saying 6 plus 2, which is 3 to the 8th. If I had a calculator, I would put that in my calculator, but for right now, we're going to leave it as 3 to the 8th. The other way to kind of justify that in your head is to say, okay, well, this is 3 squared. 3 times 3 times. This is 3 to the 6th. 3 times 3 times 3 times 3 times 3 times 3. Well, how many is that? That's 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 3s. That is why you don't change the base, you just leave it as a 3. Next one, letter B, negative 4 squared over negative 4 to the 7th. Now on this one, this is a quotient, so we're going to kind of subtract things out, and there's a couple ways to look at this, and we might do it both ways. So if we use our power, this is saying that we're going to take our base, negative 4, and we're going to take 2 minus 7. So you always take the numerator minus the denominator, which is going to give us negative 4 to the negative 5. Well, that's an acceptable answer, but when you're dealing with exponents, it's really not, because now we're dealing with a negative exponent, which we don't like. So in order to deal with that, we have to do the reciprocal, which means we're going to make it 1 over negative 4 to the positive 5. And for right now, I'm going to leave it like that. Again, if I had a calculator, I'd actually do negative 4 to the 5th power, but that's what's happening. So that's one way to do it. The other way to do it, I see a lot of kids just go, okay, well, wait a minute. I've got 2 of these on the top, and I've got 7 of these on the bottom. Well, it's kind of bottom heavy, right? There's only 2 here and 7 here. So I'm going to take 2 away. So I'm going to get rid of all 2 here, and I'm going to get rid of 2 here, which will leave me with 5. So if there's nothing left here, I just make it a 1 over negative 4 to the 5th, because 5 of them are left on the bottom, and you get right to this answer. If you use the actual quotient rule, it's fine. You just get a negative and then you have to like stick it in the denominator. Letter C, z to the 4th power, quantity to the negative 3rd power. So this is our power to a power. So I'm going to take my negative 3, I'm going to multiply it by my 4, and I'm going to get z to the negative 12th. Then I'm going to look at that and say, okay, but I really don't like a negative exponent. So I'm going to do the reciprocal, 1 over z to the positive 12th, and that's our final answer.